Hello everyone. Now today we are going to see the Freudenstein equation and Chebychev spacing problems. So here the problem statement is given. Here we have to synthesize the 4-bar chain mechanism for the given function. The function is y is equal to sine of x in the value of range from 0 to 9 degree, and the range for the output crank must be chosen as 60 degree. Is here the first position for the output link is given as 60 degree, while the input crank, the first position of input crank is given as 120 degree. So here we have to give the values for 3 position points by using Chebychev spacing method. And here fixed length link length is 52.5 mm, and first position of crank is 105 degree, and the first position of the output link is 66 degree. So as per this formula, here xj is equal to xs plus xf minus 1 by 2 xf minus xs into cos of phi 2j minus 1 upon 2 times of n, where this n's is nothing but the precision positions for 3 precision positions points, and j is nothing but the for that corresponding precision position you have to put this value here. It may be 1, 2 and 3, and precision points are 3 as per the given statement. So here you will be getting the values of x1, x2, x3 in the range of this value 0 to 9 degree. So here first value is what? 6 degree, 45 degree, 84 degree, and last value is 9 degree. So whatever the values we are getting for this x precision positions, precision points, that values will be in the range of 0 to 9 degree. Then for that corresponding value of x, you will be getting the corresponding value of function y. So y1, it is this value, then y2, y3, then up to yf, finishing value, starting and finishing value. Then the relation for the input and output angle. So theta is the input angle. So theta first, theta 1 will be equal to theta s starting angle plus del theta upon del x. Del theta is the difference between the final position of crank to the initial position, and here also del x is nothing but the difference between the final value to the starting value. So in this way we will be getting theta 1, theta 2, theta 3 by this formula, and for the corresponding theta 1, theta 3 we will be getting phi 1, phi 2, phi 3 also by putting that value. Same formula, for only difference is that here we are taking input angle and here we are taking output angle, means our angle which is made by the output link, that is the rocker link. So after getting the thetas and phi values, here we have to put that values for corresponding length. So what is the Freudenstein equation? By Freudenstein equation is nothing but cos of theta minus phi is equal to k1 cos phi minus k2 cos theta plus k3. So this equation we have to prepare for the 3 positions for first, second and third. Then after that you have to solve these equations by simultaneous equations, and after solving that simultaneous equations you will be getting the corresponding value of k1, k2, k3, and after getting that value of k1, k2, k3 you will be direct putting, these are the simultaneous equation. So after getting this k1, k2, k3 you will be directly putting that values in these expressions we are derived in the formula for Freudenstein equation. And by knowing the fixed link length, we will be getting the other link lengths also. So this is the length of A, that is the crank, C is the coupler, and this B is the crank, C is the coupler, okay, and corresponding part. Fixed link is already given, that is 52.5 mm. So in this way, we are getting the values by Freudenstein equation also, and first of all, we have to find the precision points by Chebychev spacing method. So the problems on the synthesis can be solved by using both methods, that is by using first of all Chebychev spacing, then by using the Freudenstein equation. And the Chebychev spacing method can also be found out by graphical method. Here in the first slide, if you know the range, that is delta x, then you have to plot one circle which is having diameter equal to delta x, and then you have to divide that circle into 6 equal parts in such a way that the chords will cut the horizontal line, and you will get directly the position of xx, x1, x2, x3, and lastly xf. So in this way also we can find the graphical method for the precision points. Thank you.